Okay, so this is actually an extension of the previous video. We're looking at a little parabola, and in fact, I have that right here. It's the parabola y equals x squared minus 2x plus 4. And I wanted to come up with the equation of the line that goes through the coordinate 7, 6 that is actually normal to the curve. So I want to come up with something that's going to come over in here and hit this curve at a perfect 90. Now, obviously, as I do that, there's all these different lines that could possibly hit. It's going to be somewhere in here. But what you would see is if it's going to be perpendicular to one side of this line, it's not going to be perpendicular to the other side. So what I could surmise just by looking at the pictures, I think somehow we're going to be in a situation where we're going to have identically one perpendicular, because I don't think we're going to find a way to get it to be perpendicular to the other side unless maybe it's down low or down here, something like that. So let's go ahead and see. We'll do the mathematics to see if we can come up with what makes it actually perpendicular. So back to our story here. So let's say I had this one right here. I had the equation x squared minus 2x plus 4. I already know my slope is 2x minus 2. And so what I wanted to do is I wanted to incorporate the coordinate 7, 6, and I wanted it to be normal, which means it's an opposite and reciprocal slope. So keep in mind, just as before, I'm going to have two equations. I'm going to have my line and my curve, and they have to be equal. Just like the tangents, they have to intersect. Normal lines also must intersect. That's kind of an important little feature. So that's first. Second is, in terms of their slopes, they have to be opposite and reciprocal. So whatever that original slope is, this one has to be both of those things. So let's start with this. Just like on the previous one, I kind of said it's almost like a fake story, but I'm going to start with y minus 6 equals m times x minus 7, right? Because I wanted to go through this coordinate. But I would like it to have the opposite and reciprocal slope. Now, that's going to automatically seem a little bit strange because, like, how am I going to mess with all of that stuff? And so keep in mind, it just has to work. That's kind of crazy. But I know that the y in one equation and the y in the other have to match. So I guess one thing I could do is I could replace this y right here with the original y. That's the original y that I said they have to match. And I have this right here. And so I guess a very simple thing to do would be to combine some like terms. And that actually gave me negative x plus 7 over 2x minus 2. Now, when I first did this, that's why I stopped the video and kind of redid it, because I thought, oh man, this is going to be super duper hard. And I am actually, it's legit. It's not an easy problem, because ultimately, if I cross multiply, I'm going to get a cubic, and cubics can be kind of tricky. So let's see what happens. When we cross multiply here, I'm going to have x squared minus 2x minus 2. It's going to be multiplied by 2x minus 2. And I want to find out what makes this actually work. So little distributive property time, I get 2x cubes. I'm going to point to a couple things here. I've got a negative 2x squared and another negative 4x squared for a total of negative 6x squared. I got a positive 4x and I've got a negative 4x, which actually wonderfully cancels, and a plus 4 for the end equals negative x plus 7. And one of the trainings that we've had over the years is that we always like things, if we ever can, to be set equal to 0. Now, this is a little blast from the past from math analysis, that if these answers are rational, if they are nice, they have to be factors of the right number divided by the left number. So it could be 1 over 1, 3 over 1, 1 over 2, or 3 over 2, and plus or minus. So of all of the possible answers that we have, we reduce it down to a total of 8. And it just so happens that for the sake of the time on this thing, I checked them out. And I found out that x equals 3 is, in fact, one of the roots, okay? So just kind of hold that in your head, that the value x equals 3 works, which means x minus 3 is one of my factors. So let's see what happens. Now, if that's true, the only way this can work, again, if you graph this, you're going to see it hits the x-axis at 3. I mean, you just will. So I got 2x squared, because x times 2x squared is 2x cubed. I also like to look right here at the end. And if I want -3 to be at the end, this has to be a +1. Cool? Now, let's just play connect the dots. So I've got 2x cubed, which I like. I've got -6x squared, which I like, which means I can't have any x's here because I already have -6x squared, so I don't need any extra x squareds. If I go right here, I have 1x, but then I don't have any extra, so it works. So my final factors are x minus 3 times 2x squared plus 1. So this is going to have that result happening at specifically x equals 3. And this thing is a little parabola that's been shifted up a unit, right? Which means it can never be equal to 0. So of the 3 possible answers of a cubic, only one of them is real, which actually matches with a lot of the mathematics that we did last year. Descartes' rule of signs, the fact that those other 2 imaginary roots exist, etc. So to polish this thing up, if I know there's one and only one answer, and it's sitting right here, I'm going to plug in the number x equals 3. And so I just found that the equation of this particular normal line through that value at x equals 3 is 2 times 3 is 6. 6 minus 2 is 4. I got -1/4 of an x minus 7. And specifically, what I know even further yet is that if I plug 3 into the original equation, I get 9 minus 6, which is 3, plus 4, which is 7. So I know that it's normal according to that one, and that point of intersection is going to happen at 3, 7. So let's look one more time out here at our Desmos. We just found out that the place where this is going to happen is at 3, 7. That's going to be the place where this new line is going to intersect. And we just found that instead of calling it m, we're going to call that slope -1/4. And I just found my perfect perpendicular line, or my normal line. And you'll notice this other one doesn't hit, and nothing that else will try according to the mathematics can be perpendicular to this particular one. So I'm out. I got a meeting to go to. I'll see you back in class. Thanks for joining me. Bye-bye.